Hello everyone, my name is Ayush Patil, currently studying class 11th integrated JE course from Acharya. So as being a one-day teacher for today, I will going to teach you the topic motion. In this topic, we are going to cover the what is motion, various types of motion, relative speed, and questions related to it. So let's begin. Firstly, we will see what is the motion. By going definition, the phenomenon of change of position of an object with respect to time. In given animation, you can see a car is now stationary. When I play the animation, it starts moving and moves from one place to another place. As we can see that it has changed its position with respect to time, let's say 2 seconds. So we can say that the car was in motion. Moving forward, various type of motions. Firstly, we will see the linear motion, then the circular motion, rotary motion, oscillatory motion, etc. Here are the subtypes of motion, which we'll be discussing later higher classes, and in all these topics are very deeply covered in many higher grades. So we are just taking an overlook about it. So we will see now a relative motion. Motion which can be described by a different frame of reference is called as relative motion. In this, I will going to consider many of the following cases in which you will understand clearly what is the relative motion is. So here you can see a boy is standing. Amazing. Wait a minute. Uh, yes. Imagine yourself standing beside a road, and you can see a red car and a yellow car. Imagine if a red car is moving with 100 km/h speed and yellow car is moving with 60 km/h speed. So by the external point of reference, by the point of your point of view, you will see that it is moving with a 100 km/h speed and it is moving 60 km/h speed. When I move forward, it's crosses the yellow car. If this case number two, in the same situation, if two persons are sitting in a red car, imagine two persons A and B are sitting next to each other in red car, and you are watching to them. So we will think that both speed A and B have the same speed as 100 km/h. But when B questions to A, what is your motion? Are you in motion? Then A will answer to B, no, I am not in motion, because according to him, both are moving in the same direction. So he will say that we are not in motion. So they both will stay at stationary position, and because due to they have both have same velocities in same direction. What will be the speed of A with respect to speed of B? He has a B with 60 km/h and 100, A with 100 km/h. If I want to know what the speed of A with respect to B, because they both are moving in the same direction with the different velocities. So the velocity of bigger one minus smaller one, that is speed of A minus speed of B, will be 40 km/h. So in the case 3, you will see that by imagining the frame of reference of another object, you will see a different kind of motion. By imagining other frame of reference, you will see a different kind of motion. So this is a very various what we say, the relations between the respective frame of references. Here the case 4 related to train. Speed of A and B with respect to boy. Imagine yourself, you are standing beside a station. Here's a train A moving with 80 km/h and train B moving with 40 km/h. You will see the both our trains are moving. So in your point of view, you will see that their odometer is correct and speedometer is also correct. When a speed of A with respect to speed of trains, imagine if you are sitting in a train with to a window seat of right hand side, and beside that train A is passing with 80 km/h. If you are asked what is the speed of A, you will see that the train A moves faster. When they both comes closer, the A train moves faster. So that is that the speed of is equal to B plus A, that is 80 plus 40 is 120 km/h. We can see a case 5. Speed of A with respect to B's train passenger. In the same surrounding situations, if you're sitting in the train B and observing train A, both are moving with the same speed, 80 km/h in the same direction. So you will assume, or you will see that the other train or a passenger in the other train is also stationary, because they both are moving with the same velocity in the same direction. So this is the case. So the speed of A with respect to B is 0 km/h. So I hope you should know what I have said. So we are going to discuss about what do we conclude from all these cases. Firstly, the motion may vary if the frame of reference is changed. Second, the motion of any object always should be described by making it clear that stating the frame of reference of motion will always be clear or more clear if we have stated the frame of reference. If the frame of reference is not stated, the motion may vary and the question or answers may go wrong. Analyzing the car case. The speed of car remains same as shown by speedometer when seen from an external frame of reference. If two bodies are moving with same velocities, then the both bodies are stationary with respect to each other. Analyzing the train case. The speed of train remains same as shown by speedometer when seen from external frame. The case is the case of boy is taking here place where a boy is seeing the train. If two bodies are moving opposite to each other, the velocities get added. The case number where the train are opposite to each other. If two bodies are moving with the same velocity when seen from each other frame of reference, the object is stationary. The case number 3 of train. Now here comes the displacement. I hope that everyone is clear with the distance. So we are going to directly going on forward with the displacement. Consider a position A and a position B. If I am moving in a curvy path like this, it consumes more time and the distance is also increased. But I am traveling in a straight line. The distance is less and time is consumed is less. So the straight path of anything which you are traveling is called a displacement. Go by going a formula or a definition wise, we will see that the shortest possible distance between two objects is called as a displacement. We have some notes regarding distance and displacement. In a particular situation, distance can be 0. In the particular situation, displacement can never be 0. Distance and displacement can be equal. SI unit of distance is meter. SI unit of displacement is also meter. Formula for distance is speed into time, and formula for displacement is velocity into time. The difference between speed and velocity is same, like that it is a scalar quantity and it is a vector quantity. A vector quantity allows it requires a direction to specify. Here is a one question. So let's try. First, I will read and then explain to you. Train A and B starts at the same time. Train A travels at 55 km per hour from station P to station Q, and train B travels at 80 km per hour from station Q to station P. They cross each other after 1 hour 36 minutes. What is the distance in kilometers between station P and Q? Here you can see a train moving with 55 km per hour and train B moving with 80 km per hour. Here is a station, a train A and train B with the station P and station Q, and they moving opposite to each other in such a manner. So here is what is the distance between P and Q. So for finding that, we have the formula is speed is equal to distance upon time. The distance is equal to speed into time. So speed here are given two speeds, 80 kilometer per hour and 55 kilometer per hour. So I'm a question to all of you: what will I should take? What should I take for calculating the distance? Hello. So I will answer. As we have discussed earlier, that the relative speed is taken over here. So 80 plus 55, we are taking addition of both of the speeds because they are moving in opposite direction. As you can see, they're moving in opposite direction, the case which we have discussed earlier. So in this case, we have to do that the speed is equals to speed is distance upon time. So distance will be speed into time. Moving forward with the solution, you will see the distance is equal to speed into time. Speed to be taken relative. So the relative speed will be 55 plus 80 multiplied by 36 upon 60. It is divided by 60 because we have to convert into hours. The time is given into minutes. So we are converted into hours. Speeds are added due to the trains are moving in opposite direction. Therefore, it will be 135 multiplied by 16 upon 10. The answer goes for 216 kilometer by solving and simplifying following. Thank you for listening patiently. Hope you understood all the concept taught. Thank you and have a nice day.